Today we're going to be looking at a more secure way to cold store data. Now, where you might want to do something like that is with something like a hardware crypto wallet. When you go through the setup process for these things, you end up generating a seed value which can regenerate your key material. And you write it down on a bit of paper like this. So you get 12 words, you write it down, and then you stick it in your safe and you're all good. You're all good until the house burns down and so does your safe. This bit of paper won't last very long in that circumstance. The other thing, it might get, your house might get flooded and this might get soaked in water and get destroyed that way. The other problem that you might have is that someone might break into your safe and then be able to see the seed value, in which case they can make a copy of your hardware wallet. They might simply just run off with the safe and break into it later on. So we're going to have a go at seeing if we can get around that and seeing if we can create a more secure way to store data such as recovery seeds or any other data that you might want to encrypt. So how we're going to do that is we're going to use a Raspberry Pi. Now this is an older model Pi that I had laying around. It doesn't have Bluetooth, it doesn't have Wi-Fi, but it's got a hardware random number generator on it. And that will help us use modern ciphers to encrypt data, and then we can record that data down and then safely store it and back it up in other places. So I've gone and imaged the SD card for my Raspberry Pi with Raspbian, and I've booted into the Pi, and now I'm going to go and set up the keyboard for the Raspberry Pi so that the special characters work properly. So to do that, we'll go into the Raspberry Pi config tool, and go into the localization options and change the keyboard layout, and then we'll select the keyboard that is currently set on. And we want to change the language to other. And for me, I want to select English US. Go up and select English US again. And leave all these options as default. Then we'll exit out of our setup. And now when we use our special characters, they should be working appropriately. Now we're going to install the cryptographic library for Python. So before we do that, we'll update the package list. Now we'll install the Python 3 cryptography package. Now we'll get a Python script that I created from GitHub using AES that'll allow us to encrypt our data and safely record it down. Once we've got the script, we'll need to make it executable. We'll also run a quick check to make sure that the hardware random number generator is working with the Raspberry Pi. There we can see our random number generator service is running, and it's using the device of dev/hwrng, which is our hardware random number generator. You can also run a test against the hardware random number generator just to make sure it's working properly. To do that, we'll test it against the operating system entropy pool, which the hardware random number generator is feeding, and then it'll run through and perform a series of tests, and it'll give you an idea of how random that pool is. So there we've run our test 1,000 times. We've had 999 successful runs and 1 failure. From what I understand, under 10 failures is acceptable. So a couple more things you might like to do before we encrypt our data is we can disable the Bluetooth and Wi-Fi modules on our Pi at boot time if you have those. So we'll go ahead and do that. So to do that, we need to edit our boot config. We'll go down the bottom here and we just add the lines like so. And then we'll save that. Another thing you might like to do is disable some of the networking services just to make sure that there's definitely no wireless network starting when it boots up, to make sure that it's air-gapped. So to do that, we can use system control to disable services such as networking. Then we can disable DHCP server. And also we can disable the wireless client. Now we can reboot our machine, make sure the Ethernet cable's not plugged in anymore if that's how we want to do it. And then you should have an air-gapped machine that has all the bits and pieces it needs to encrypt and decrypt data. So now that we've rebooted our Raspberry Pi, we've got no internet connection to it or network connection at all because we've air-gapped it and we're running minimal services, we can now safely go and encrypt our data. So to run our script, we'll use the script with the -e flag, that stands for encryption. We can use the -d argument to decrypt data. So we'll start out with -e first. The script will then ask us for some plain text data that we want to encrypt. So we're going to encrypt the value of super secret data. We'll then use a passphrase of correct horse battery staple. And the script will encrypt our data for us. Then if we want to verify, we can then use -d. It'll then ask us for the values that it's just spit out. So it'll ask us for the salt value, and then it'll ask us for the initialization vector, and then it's going to ask us for the ciphertext. And then it'll ask us for our passphrase again, which was correct horse battery staple. And there the script gives us back our encrypted data. So now that we can now that that works, we can take these values and safely record them down for storage. Now that we've got our encrypted data, we're going to punch that data into this metal plate using these punches and this little tape guide that I've made up. So the first value I'm going to record is the salt value. And then we'll record the initialization vector. And now we'll do the ciphertext. And now we've got our data punched into our metal, let's go test it. our fire test is done, we'll now conduct a flood test. So we've given our encrypted data plate the good old fire test, and you can absolutely still read all the data that's on this plate. So yeah, it's going to survive a fire just fine. Also obviously survive a flood just fine. And if you make backup copies, it'll also survive if the plate gets stolen, because you'll have backup copies of it. So yeah, if you'd like to see more projects like this, hit that like button, hit the subscribe button, and you'll get notified when more content comes out.